So we want to put our newfound knowledge about the normal curve to the test with a couple examples. Now remember that when we draw a normal curve, it's symmetric around the mean, mu. Remember that means the mean is the center. And that's going to help us down here because we want to determine what the center is, what the mean is for these two graphs. So if we look at curve number 1, which I highlighted in orange here, we can see that the central line is hitting at 0. So that graph has a mean of 0. And the other graph has a central peak right here at 3. So this graph on the right has a larger mean. And you can tell because it's to the right where the curve has its peak, right? Because where the curve has its peak for a normal curve is the mean. Larger because numbers over on the right of the number line are larger than numbers on the left. Okay, so that's the first thing we want to note about the impact of the mean and standard deviation on a graph of a normal curve. So the mean is the center, and that implies that when you have a larger mean, the graph will have a center on the right. And a smaller mean will have a graph that has the center on the left. Now, what about the standard deviations on these graphs? So if we look at them, the standard deviation is a little bit above halfway. So if you think of the bottom of the curve where it's having the asymptote at the x-axis, and the top of the curve, it's just a little bit above halfway. So it's right about there. And that distance is from 0 to 1. So that's a standard deviation of 1. Similarly over here, standard deviations is about 4, and that was about 3, and that's a distance of 1 from 3 to 4. So these two graphs had the same standard deviation, and you can tell that just by looking at them because they had the same spread. They had the same shape. So standard deviation is a measure of spread, which we knew anyway from when we first learned about standard deviation. But how it manifests in this normal curve, since they had the same standard deviation, they had the same spread. These two curves are identical, it's just one is to the left of the other. All right, now what about example B, or 1B I should say. Okay, so both of these curves have a central line right down the center at 0. So these curves both are centered at 0. Their central peak is at 0. So this is 0 and this is 0, right? The mean is the center, and so if they have the same center, then their peak will be at the same space. If I could spell same. The same center. It's the same place for the central peak, right? On the x-axis. Right? They're both centered at 0 for their highest point. All right, what about their standard deviations? Okay, so the standard deviation on this first one, it's a little bit above halfway. That distance right there is 2, from 0 to 2. So the standard deviation on the first curve is 2. The second curve has a standard deviation of 4, right? It's a little bit above the halfway spot. So about 4. What does this tell us? Okay, so if we have, since the standard deviation is the spread, if we have a larger spread, or larger standard deviation, that means the graph is wider, more spread out. But you can spot it because the graph is wider, right? More spread. And if the graph has a smaller standard deviation, that means the graph would be narrower. Right, less spread out, more packed in. Okay, so now that we understand how the center and the spread change based on the mean and standard deviation, let's look at an example that puts all of that together. All right, so we have four normal curves here, all of different shapes, so different widths, different standard deviations, and different means. And we want to figure out how we can tell which one is the largest mean, which one's the smallest mean, and everything in between, because we're going to list those graphs in order from the largest to the smallest mean. Now remember, the mean is the center. Okay, so this is going to be pretty straightforward, right? The central line is over here, right? So if we look, the central line is right here, the central line is right here, and so on. And so the central lines go in order from lowest to highest as you move from left to right. Because on the x-axis, which is this line down here, values that are lower are to the left and values that are higher are to the right. So the smallest mean is the graph that has the center that is farthest left, which would be graph C. All right, then we want to go in order. So we're going to list the graphs in order. So this is why, actually, let's put that right there. So that's why C is the smallest one. And then we would go in order. A would be the next one on the number line, then D, and then B would be the last one. And B is the last one because it has the largest mean. And you can tell because it's farthest to the right. I'll put this the other way. Center is farthest right. And actually, I'll write this other one the same way, just so that they match. Well, that was very easy. No, not hard at all, because the centers are really easy to spot which one's small and which one's big. No problem. All right, what about the standard deviation? Well, that's a little bit trickier. Standard deviation is a measure of the spread, right? So if center is moving left to right, that's all you're trying to do. But what does it mean to have a small standard deviation? Remember, a small standard deviation means you have a narrow graph. So you actually want to go from the narrowest graph to the widest graph. Okay, so the smallest standard deviation, let's write this out, would have the narrowest graph. All right, which graph is the narrowest graph? Well, it's very obviously D, right? D is the skinniest one, right? It has the least distance between the center line and the curve. So that's D. All right, the next narrowest is actually A. You can see right here, that distance from the inflection point out to the center line, from the inflection point out to the center line, right? That's the standard deviation. So that's A is next. Then C, from the center point out to the line is right there. So that's C. And then B is the last one. B has the largest standard deviation because it's the widest. Now, because these graphs all add up to 1, there's an inherent issue with this, right? If you make the graph wider, because you have to have the area under the whole curve make 1, what happens is the graph shrinks down on you. It actually lowers the peak, right? And that's not happening, that's happening inherent to the fact that the standard deviation is shrinking and the area has to make 1. So that's another way you can kind of spot them visually, but it's not really the reason why it's happening. It's kind of a lurking variable going on in the background, to quote an earlier chapter. Let me show you on Desmos really quickly. So if you look at this normal curve, if I make the m, the mean, go larger, see what happens? I'm making the m go larger and it moves the graph to the right. If I make it smaller, it moves to the left. The mean is a measure of left and right for a normal curve. The standard deviation is a measure of the width and the spread. It will automatically happen that the peak gets taller and larger, but that's just because the area under the whole curve makes 1. So when I make the spread go larger, see, it gets more squat, right? It gets wider spread, right? The distance is greater between the mean and the standard deviation. When I make it the standard deviation smaller, the graph gets narrower. And that inherently makes it taller, but it's really the narrowness that's happening. And I'll link to this graph in the video for this as well for you guys to play with.